in this beam, if you read the statement, analyze the continuous beam shown in figure by three moment equation method. If support B sinks by an amount of 10 mm, draw the shear force and bending moment diagram. Take flexural rigidity EI uh, as uh, given in the diagram. Okay, E is same, but I value is different. I is 1I for span AB, 3I for span BC, and 2I for span CD. Okay, now there is no external loading given, only sinking of support B is given. So making use of this data, we have to analyze this beam. So again, we have to first of all look at boundary conditions. So let us see what are the boundary conditions. Boundary condition is uh, end supports. First of all, see end supports. Both are simply supported ends. So MA and MD both are zero values. Next, we can now apply three moment equation for spans AB and BC. So let us see what will be the equation. So this is our equation. MA into 4 upon I plus 2MB into bracket L1 upon I1 is 4 upon I plus L2 upon I2 is 6 upon 3I. Why? Because I value is 3I for uh, BC span. Then MC into L2 upon I2. So 6 upon 3I. It is equal to 6 EI delta upon L1. Please remember there is no 6 A1 X1 bar upon L1. There is nothing. Why? Because 6 A1 X1 bar, it will be only coming into picture when there is external loading on the spans. There is no external loading. So what is this part? This is these are the terms coming because of settlement of supports. Okay. So settlement of support delta, it is already given 10 mm. It is converted into meters. So it is 6 EI delta upon L1 plus 6 EI delta upon L2. Okay. So 10 is converted in 10 mm is converted into meters. So 10 into 10 is to minus 3. L1 is 4, L2 is 6. Fine. Now uh, we have further simplified this equation as 6 MB plus MC, it is equal to 6. So this is our problem, and only last term in the equation of three moment equation will be applicable here, which is 6 EI delta 1 upon L1. Okay. Now same equation is applied for spans BC and CD, and it is further simplified. Please remember, for CD span delta is 0. There is no sinking of support C. Only support B sinks down, not C. For CD span delta is 0. However, for BC span delta is there. Okay, and it will be taken minus. Here we have taken plus. Please remember. So MB plus 5 times MC, it is equal to minus 240. Why is it taken plus here? Again, I will repeat the explanation. B is going down. So with respect to A, when B is going down, we are assuming this delta as positive. Moment will be negative, but sinking will be treated positive. Okay. And relative to B, C is up. So in this case, when we are applying this for BC span, here it will be taken negative. Okay, it will be taken negative. Now, now we shall further simplify this problem. So after solving equations 1 and 2 simultaneously, we are getting MB as 111.72 and MC as minus. Please see, one moment we are getting positive, another moment we are getting negative. So I have a freedom to consider uh, the part below the reference line as positive, another part above the reference line as negative. I can consider vice versa also. I can plot this diagram as 111.72 ordinate above the reference line and this 70.344 value below the reference line. I can draw its mirror image also. That will also be correct.